Hi guys, so this is another pre-recorded video for our subject General Chemistry 2. So in this pre-recorded video, we are down to our week 5 of the of General Chemistry 2 wherein we are going to tackle colligative properties. But first, of course, let's define what is colligative properties. Ah, by the way, you need to make sure that you have with you your calculator and of course your periodic table because we will be needing that one in the problems that we will be solving later. So the targets of for this particular pre-recorded video is for you to be able to identify what are the different colligative properties and of course for you to solve some colligative property problems. Now let's define what is colligative properties. So when you say colligative properties, it's actually a property that depends on the concentration of your solute molecules. So we are in particular with the concentration or the amount of solute that is actually present in a particular solution. So take for example, you have a water in a beaker and you wish to put a solute, which is sugar in this case, therefore producing a sugar solution. So, colligative property there is the property of the solution wherein you are concentrating on the amount of solute. So, what is now the effect of that particular addition of a solute, which is a sugar? And later on, we will identify um, bakit nga ba magkakaroon ng changes in terms of the property ng isang ng isang liquid because of just the addition of a solute. Okay? Now, um, colligative properties include vapor pressure lowering, the boiling point elevation, and the freezing point depression, as well as the osmotic pressure. But in this pre-recorded video and in our general chemistry 2 subject, we will just tackle vapor pressure lowering, the boiling point elevation, and the freezing point depression. So we will just have three colligative properties. So just remember that when you say colligative properties of a solution, it is actually a property of solution that depends on the number of solute particles, or let's just say not number but the amount of the solute particles. So when you say colligative, that word means collective effect. So there is a collective effect when you say, if you're going to add, as like what I have as an example a while ago, if you are going to have um, a sugar added to your liquid, which is kunwari water, then of course you can create a sugar solution. But because of the addition of that particular solute, some of the properties now of the liquid, which is water, will change. Because of course, you now have a different substance, which is now the sugar solution. So that means with the collective effect, okay, kahit hindi naman nabago yung solvent mo, still water pa rin naman siya, but because of the addition of a particular solution, of a particular solute, therefore creating a particular solution, then there is now the what we call collective effect. There is now an effect of that particular addition of solute. That's why there are some changes in the property of our solvent. So again, in solution, please don't forget that because of the addition of your solute, okay, the solute particle, and if you're going to add it with a solvent, you will always come up with a particular solution. And because of the addition of that particular solute, okay, because of the addition of this particular solute, then the property of this solvent that you have here will change, okay, therefore creating a particular solution. So these colligative properties are such as boiling point, vapor pressure, and freezing point will now change because of the addition of your solute. So that's what I have mentioned a while ago. Um, This colligative property means it is a collective effect of the addition of your solute in your solvent, therefore having a particular solution. So one of the colligative properties that we are going to discuss is the vapor pressure reduction. So the vapor pressure reduction has a formula of P is equal to x sub 1 P prime. Okay, we read it as P prime. Later on, we will know what they mean by P prime. So for vapor pressure, it is all thanks to Raoult's. Okay, he develops the Raoult's law, and it states that the vapor pressure of your ideal solution is equal to the vapor pressure of your pure volatile component multiplied to your mole fraction. So as you can see, there is still an application of the concentration units here, specifically the mole fraction. This happens when a non-volatile solute is added to a volatile solvent. Now, let's review the properties of liquid that we have just discussed in Chapter 2. What do you mean by volatile? When you say volatile, these are the substances. It could be solid, it could be liquid, wherein it could just easily skip its phase, okay, from a solid or liquid into gas. So a very good example of volatile compounds are acetone. So because if you just leave an acetone there, it will just take like 30 minutes to para mangalahati yung volume ng acetone, or maging 3/4 na lang yung matitira, and so on. So yun, that is what you mean by volatile compound. So when you add a non-volatile solute now in your volatile solvent, okay, when you say volatile solvent, madali mo lang siyang ma-change into vapor pressure, into a vapor. So when you add now a non-volatile solute, so of course, the property now of that volatile solvent will change. It will not be volatile anymore because of the presence of your non-volatile solute. Kaya nga tinawag natin siyang collective effect because of the addition of a non-volatile solute, your solvent now will change its property. So that first property is the vapor pressure. So your formula is P is equal to x sub 1 P prime, where your P is just the vapor pressure of your solvent over a solution, and your x sub 1 is the mole fraction of your solvent. Tatandaan po natin yan, yung mole fraction po na hanapin natin ay hindi kay solute, kundi kay solvent. And your P prime is the vapor pressure of your pure solvent. Okay, so that means that this P here is actually the vapor pressure before adding a particular non-volatile solute. And this P that we have here is the after, okay? So it's just simply the multiplication of your P prime, which is the pressure before adding a solute, and your mole fraction of the solvent. So let's try solving one problem involving vapor pressure. So we have here the vapor pressure of pure water at 26 degrees Celsius is 25.21 torr. What is the vapor pressure of a solution which contains 20.0 grams of glucose, that is C6H12O6, and 70.0 grams of water? So of course, the first thing that you need to do is to list down all the given that you have. So do you have the vapor pressure of your water? You have it there in your problem. So the vapor pressure of pure water, that means that is the vapor pressure of your solvent before adding a particular non-volatile solute. So that is actually your P prime. So your P prime value is, okay, 25.21 torr. Next is the mole fraction. Do you have the mole fraction of your solvent? In this case, it is not given. What is only given is that you have 20 grams of your glucose and a 70 grams of water. So, mamano-manohin natin ngayon. We are now going to solve first for the mole fraction of your solvent before proceeding with the formula that we have here for vapor pressure reduction. So, let's start. Let's start by having 20.0 grams of glucose, that is C6H12O6. So, just remember how to solve mole fraction. Of course, since it's mole fraction, we need to change our grams into mole. So, in every 1 mole of C6H12O6, please pause the video and solve for the molar mass of your glucose. Then if you already have the molar mass, that would be 180.156 grams of your C6H12O6. All you have to do is to cancel out the grams. There you have it, and you can now have the moles. That would be 0.110 mole of your C6H12O6. Of course, that's not the final answer. It's still the mole of your C6H12O6. Let's find out the moles of your water, which is your solvent in this case. So you're given 70 grams of water. So multiply it with, in every 1 mole of water, you have, find the molar mass of water, that's 18.015 grams of water. So cancel out the grams, then you can now have 3, okay, that's 3.8857 mole of water. Okay, so we have only here the number of moles. We don't have yet the mole fraction of our water, okay, which is the solvent. So let's solve for the x, okay, because it's a mole fraction. Solve for your x sub water. And you now have the molar mass of water, the number of moles of water, which is 3.8857 mole, divided by, what should be the denominator in the mole fraction? It should be the total number of moles of the components of the mixture. In this case, that would be 3.8857 plus 0.1110 mole. So you cancel the mole. So what is the mole fraction of your water? It's 0.972. Can we proceed now to our formula? Since you already have your x sub 1, which is 0.971, then yes, we can now proceed in solving letter P, which is the pressure of your solvent if it is in a solution. So you have P is equal to x sub 1 P prime. So your x sub 1 is 0.971. There's no unit because that is mole fraction. Multiply to 25.21 torr. 25.21 torr. Then all you have to do is to obtain the product, and you will get P is equal to 24.5 torr. That means that the vapor pressure of your water, okay, if you're going to add the non-volatile solute in the solvent already, then that would be 24.5. As you can see, from 25.21, naging 24.5 torr na lang siya. That means that there is a vapor pressure reduction. There is a reduction of your vapor pressure from the before and after creating the solution. So this is vapor pressure reduction. So all you have to do is to memorize the formula. That is P is equal to x sub 1 P prime. Next colligative property is the boiling point elevation. So we are expecting that the boiling point here will increase because of the word elevation. So the formula is delta T sub B is equal to K sub B times M. Your M here is actually your molality. Your Kb is actually constant value of a particular solvent. And of course, delta T sub B means there is a change of temperature in terms of its boiling point. So later on, tingnan natin how are you going to use that value to identify what will be the new boiling point of the solution. So the idea of boiling point elevation is that when you have a non-volatile solute, ganito lagi kasi yung situation. You always have a volatile solvent. You add now a non-volatile solute. So what will happen now to the solvent's property? Mababago. So the first property na mababago sa kanya is yung na-discuss natin, which is the vapor pressure reduction. That means the vapor pressure of the liquid, no, sorry, of the water, which is your solvent, will reduce when you add non-volatile solute. Ngayon, how about boiling point? If you're going to add a non-volatile solute in a certain solvent, take for example, nag-add ka ngayon ng sugar sa water, what do you think will happen to its boiling point? Actually, alam na rin natin na dapat mag-i-increase siya. Kasi nga, mas maraming ngayon yung bonds na kailangan nating i-break because of the presence of your sugar molecules. So, because of the presence of those bonds na medyo marami-rami, so, kailangan mataas din yung temperature, okay, to gain more kinetic energy so that those molecules could break their bonds, okay, and attraction with each other. Kasi hindi lang naman bonds yung meron because remember, we also have intermolecular forces. So, going back here, when you say boiling point elevation, so when a non-volatile solute is added to a volatile solvent, a higher temperature is needed for you to make sure that the solution will reach its boiling point. Okay, so tataas dapat. So, your formula is change of your T sub B, which is actually the change of temperature. Okay, ang makukuha lang natin ay change of temperature. So, mamaya kung ngayon tatanong sa inyo ay what is the new boiling point? So, of course, may kasunod pa tayong solution na gagawin after solving for your delta T sub B. Then, for your K sub B, I'm sorry, that should be sub B, it is a constant value of the molal boiling point elevation, which has a unit of degrees Celsius per molal. Okay, again, that M there is not that's not meter. That's definitely not mole because mole is MOL. So M is a small letter M, of course, is molality. So there, small letter M is molality. I guess you have to memorize this one. The KB value of your water, the K sub B value, this is constant, the K sub B value of your water. Most likely in some of the problems that I encountered in colligative properties, kapag ka hindi naman siya tubig, like for example, the solution na ginamit could be like any alcohol. So, ethanol, methanol, binibigay naman nila si K sub B value. So, you don't have to memorize. Pero, yung mga problem that involves water as their solvent, hindi na nila binibigay yung K sub B. So, parang kailangan nyo talaga siyang i-memorize. So, for your K sub B of water, that is 0.52 degrees Celsius per molal. Okay, so tatandaan yan. Your K sub B for water is 0.52 degrees Celsius per molal. So, that is the constant value K sub B. Now, let's have an example under boiling point elevation. So, we have here a problem. What is the boiling point of an aqueous sugar solution containing 100 grams of sucrose, that is C12H22O11, in 500 grams of water? So, as you can see, we still need our molality. That's why we are given with two masses, the mass of your solute and the mass of your solvent. So, we need first to solve for the molality of your solution for you to be able to compute for your change of T sub B. Okay? So, remember how to solve for the molality. Molality, M, small letter M, is equal to the mole of your solute divided by the kilogram of your solution. That's solvent. Mole of your solute divided by the kilogram of your solvent. So, of course, we need first the number of moles of your solute. So, your solute here is definitely sucrose. So, you have 100 grams of C12H22O11. Okay, change that one into mole. So, kindly pause the video and solve for the molar mass of your C12H22O11. So, in every 1 mole of your C12H22O11, you have 342.297 grams of sucrose, C12H22O11. So, you cancel out the grams. Now, you have the mole, which is 0.2921 mole of C12H22O11. So that's your number of mole. But of course, that's not yet the final one because we still need a kilogram of your solvent, but you're only given with a 500 grams. So I hope you know how to convert that one already so that I could just directly write it down here. So your mole of your solute is 0.2921 mole of your C12H22O11 divided by the kilogram of your solvent. So just change this one into kilogram. You have 0.500 kilogram of your solvent. Okay, then your molality now will be 0.585 small letter m. Okay, so can we proceed now to our formula? Yes, so let's identify first, of course, what is your solvent in the problem. The solvent in the problem is water. So we know that your Kb value now, okay, your Kb value is 0.52 degrees Celsius per molal. Okay, so we can now proceed directly to the equation. So the change of your T sub B is equal to K sub B times your molality. So your K sub B is 0.52 degrees Celsius over molal times the molality, which is 0.585 mole. So you can cancel the molal. Now, what do you have here? The change of your T sub B, the temperature in your boiling point, is 0.3042 degrees Celsius. Okay, ano po ang ibig sabihin niyan? Yan lang yung change. Okay, change lang yung sinolve po natin. But you were asked, what is the boiling point of the aqueous sugar solution? That means you were asked, ano ngayon yung after na boiling point nung nilagay mo na yung sugar sa tubig. So, all you have to do is, of course, to add. So, you will now know that the temperature, the final temperature, that would be TB of your solution. Okay, T sub B of your solution is equal to, of course, the temperature, the boiling point temperature of your water plus the change of temperature. Okay, the change of temperature of your water. So that would be change T sub B. Miss, bakit po tayo nag-add? Bakit hindi po natin minus? Because remember, we have a boiling point elevation. There is an elevation. So that means we need to add something to the to the constant boiling point value of a certain solvent. Okay, that's why we need to solve for the change of your T sub B. So we know that the boiling point of water is, of course, 100 degrees Celsius. So all you have to do is to add that one to the change of your T sub B. That's 0.3042. Okay, 42 degrees Celsius. And you can now have the T sub B of your solution is equal to 100.30 degrees Celsius. So you can now box your final answer since this is now the boiling point of your aqueous sugar solution. Okay? So, ibig sabihin lang nito, nung nag-add ka ng sugar, okay, nagkaroon ng change ng temperature, boiling point temperature na 0.3042. Okay? At dahil alam natin na 100 degrees Celsius ang boiling point in water, so all we have to do is to add that change to the 100 degrees Celsius for us to know what is the new boiling point of the sugar solution. So that is boiling point elevation. Next one is the freezing point depression. This will be the last colligative property that we will discuss in this pre-recorded video, even in our synchronous, because we only have 3 colligative properties in our MELCs. So, the freezing point depression. So, in the freezing point depression, it's actually just almost the same with the boiling point elevation. The only difference is that, of course, there you have this T sub B because it's the boiling point, but here you have the T sub F because it signifies the temperature in the freezing point. So your change or your delta T sub F is actually the change of your temperature in the freezing point. Your K sub F is another constant. Okay, it's a constant value of the molal freezing point depression. with a unit of degrees Celsius per m or molal. Then of course, your small letter m, which is your molality. So ano ang ibig sabihin ng isang freezing point depression? When you have a volatile solvent and you add a non-volatile solute, the freezing point lowers. Okay, bababa dapat. So tatandaan natin yan. Let's have a sample problem under freezing point depression. So what will be the freezing point of an aqueous sugar solution containing 100 grams of sucrose dissolved in 500 grams of water? So it's actually just the same with the previous problem, but in here, ang hinahanap naman natin is the freezing point. So, by the way, you have to memorize as well the K sub F value of your water. Okay, so if the K sub B or value of your water is 0.52, for the K sub F of your water, that is 1.86 degrees Celsius per molal. Okay, so tatandaan natin yan. We already have your K sub F. Now we're just looking for your molality. So let's solve for your molality. So your molality is M is equal to the mole of your solute. Okay, that's mole of your solute over the kilogram of your solution. So of course, we need the mole of your solute. So it's just the same. 100 grams of your C12H22O11 times, and every 1 mole of your C12H22O11, you have 342.297 grams of C12H22O11. Then cancel out the grams. Then you have now the number of moles, 0.2921 mole of your C12H22O11. This is just the same problem, the same calculation with the previous one. Okay, so medyo mabilis ako. So you have the mole. So you already have the mole of your solute, which is 0.2921 mole of your sucrose, C12H22O11. So all you have to do is to divide that with a kilogram of your solvent. So you have 500 grams of water here. So just change that one into kilogram. That would be 0.500 grams of your solvent. Then you will get the value of your M, which is 0.585 M. Okay, can we calculate now for your T sub F? Change of your T sub F? Yes. So the change of your T sub F is equal to your KF, which is 1.86 degrees Celsius over molal, times the molality, which is 0.585 M. So you cancel now M. So you have an answer of 1.0881 degrees Celsius. Ano ibig sabihin yan? That is the change of the temperature. But because this is freezing point depression, dapat bababa. Okay? Dapat po bababa. So you have, let's identify what is the temperature of your freezing point of the solution, T sub F of your solution. So that is by having the temperature, or sorry, the freezing point temperature of your water, which is your solvent here. Then of course, dahil depression siya, may pagbaba, ima-minus natin siya dun sa change of your T sub F. So that would be 0 minus 1.008 degrees Celsius. Then you will get a T sub F of your solution, which is negative 1.088 degrees Celsius. So box your final answer because that is now the freezing point of an aqueous sugar solution. So of course, maintindihan natin bakit nga ba bumaba yung freezing point. Okay? Kailangan mas babaan mo siya kasi nga there is now a presence of your solute particles. Okay? Which is in this case your sugar. So that's the end of our colligative property pre-recorded video. So I hope that you learned something about the different colligative properties. We will discuss this more during our synchronous meeting, but only one synchronous meeting because we need to proceed to thermodynamics. So if you have questions, just leave it below in the comment section. Your presidents are commenting the section. And all you have to do is to reply there with your question so that during our synchronous meeting, I can answer some of your questions. There. So thank you so much for watching and goodbye.